Okay, we're going to have a look at this example. I have two resistors here, R1 8 ohms and R2 is 5 ohms, and they're supplied from 12 volts. So what I'm going to do first is find the total resistance of the circuit, and then I'm going to find the current flowing through each resistor by calculation. So I'll just split this down the middle here. And we know that 1 over RT equals 1 over R1 plus 1 over R2. And that becomes 1 over 8 plus 1 over 5. So that becomes 0.125 plus 0.2 equals 0.325. Now remember that that is 1 over RT. I need RT, which is 1 over 0.325. So when you were doing your reciprocal calculations last week, what you can do is leave 0.325 on the display when you've done your total and find the reciprocal of that, and that comes to 3.0. I'll call it 3.08, and that is ohms. Okay, so RT equals that. Now to find out the total current flowing into the circuit, I think you've seen that there. To find the total current flowing into the circuit, IT equals a voltage divided by a resistance. So if I cover that one up, it's a voltage. The voltage I'm after is 12, and the total resistance of the circuit is 3.08. So IT equals 12 divided by 3.08. Is 3.89 amps. Remember your units: amps, ohms, volts. Never just write a number down in an exam, always show your units. Very important in electrical engineering. If you get it wrong, mistakes can be made quite easily, so get that right. Right, when the current gets here, it splits. Some of it goes down through there, the 8 ohm resistor, and some of it goes into the 5 ohm resistor. So to work out the current in both, we know that the voltage is going to be the same across each resistor. It's a bit like your network. The voltage is approximately the same across everybody's household. Right, so I need to find IR2. I need a voltage and I need a resistance. Well, I know the voltage is 12. I'll write it out properly first of all. It's Vs over R1 equals 12 divided by 8, and that equals 1.5, and the unit is amps. IR2 equals Vs divided by R2 equals 12 divided by 5, and that comes to 2.4, and that should be amps. So there we are, 2.4 amps. And as a quick check, the current going through IR2 is 1.5. Sorry, that should be IR1, mistake there. The current going through IR1 is 1.5 amps, the current going through IR2 is 2.4 amps, and if you add the two together, 3.9, it comes to IT, approximately, and that proves that the current is split up here and it's joined up together here, and it goes back to the origin. So IT is here. So we've got the supply current, and then you've got the current going through R1 and the current going through R2. Okay, I'll give you one last look at the board before we switch it off. There it is, like that. Okay, thanks very much.